Hello, everyone, and welcome to Handmade Hero Show, Recode a Complete Game live on stream. I think today I'm going to go ahead and get started on making some modifications to our world storage. I was talking about doing this about 2 weeks ago, but I wanted to create a memory viewer so we could kind of see some of the results of what we were doing in a more direct way. And so that's exactly why we built over the past 2 weekends, we built a little thing that tracks and shows all of our memory. It's pretty cool, actually. I was pretty happy about that. It looks nice, and it allows us to see what's going on in there pretty easily. What I'd like to do today, however, is get started. There's some more stuff we probably will do to our memory view in the end, like add some scrolling and maybe some better display of some stuff. It's not perfect, but it's good enough. For now, I think I'd like to go ahead and get started on that modification that I wanted to make. Let me just go ahead and show what... did that? There we go. Let me just show what I'm talking about here, and then we'll get started on the new stuff. So if you take a look at the game as it runs today, now we didn't have this ability to do before, but now we do. We can go in here and look at things like what our memory layout is. In this case, this shows our arenas that are currently active, and it shows, who's got what memory allocated where. Again, this is pretty nice. It shows us how our breakdown is, and it breaks down exactly as I want. Most of our memory is spent in asset caching room that we can use for caching assets, specifically sounds. And that's pretty much what we want. Ideally, we would have most of our memory taken up there. And the reason for that is because it's very fungible. If we need to run on a lower-end machine, we can always just reduce the amount of caching we have there, or use lower quality sounds, and so on. So seeing your memory footprint end up mostly in asset storage is kind of what you want. If your game is taking a ton of memory, there's not a lot you could do about that, right? And so it gives you a lot less flexibility to target lower-end hardware. If your game is taking a gigabyte of memory, well, then there's really nothing you can do. You've got to change, you've got to go work on your game code if you want to ship on something that doesn't have a gigabyte of memory available for it. So we can take a look at this. We also have the ability to turn debug information on and off. This is information that's strictly used to record things like our profiling and our memory. So we don't really count that because, again, that just goes away when we compile our release version. So we don't really need to see that. We also have call site view. That allows us to see where this memory is being taken. So we can kind of see, like, specifically in which pieces of the code are responsible for the majority of our memory. It's pretty easy to see here who's taking up most of our space. We've got a sort of a 70 meg layout for our game mode, and 60 megabytes of that is right here. And so that kind of tells us who is taking the lion's share of things. If we don't already know, this tells us pretty quickly what's going on with that. So that's nice too. And then finally, we have like our block layout diagram. This is really nice because it's an easy way to visually see what's going on. And you can see quite clearly here, like here's all the asset storage. It's just a giant big block that's just used for audio streaming. It doesn't do anything else. And so that's, again, like I want to see it this way. This up here is the part that concerns me a little bit more. This is our world storage. Each one of these is a chunk of storage in the world data structs. And I don't know if you can sort of see what's going on here, but basically this is the most recent block of storage, and it hasn't been filled up yet. That's why it's the most recent one, right? Things are getting added in there. And this is what concerns me at the moment, and what concerns me a little bit more long-term, and one of the reasons I want to sort of start to work on the entity system a little bit now, because we're kind of moving into a place where that's really the last thing we're going to be working on. If you think about it, like almost the entirety of the remaining game implementation we have is going to be in the entity system, because the entities are what sort of determines the gameplay. So as we're transitioning into working more and more just on how entities work and how they behave, this concerns me because we really don't have that many entities in the world right now. Now, I guess it's deceptive to say that because we sort of do. I mean, there actually is, if you can think about the fact that all of this stuff, every last thing here is an entity. The ground pieces are an entity. These are entities out here. That's an entity. That's an entity. So there are quite a few entities if we actually zoom out and look at how this whole world is defined. There's quite a few, actually. So it's not like it's that small of a world, but Would we like to support much larger worlds? Absolutely, and everything else in our system does that just fine at the moment. There's nothing else in the system that's going to prevent us from creating giant worlds. The memory burden is the only thing that would sort of put a limit on it. And obviously there are things we can do in our system if we really wanted to support absolutely ridiculously huge worlds that are effectively impossible to ever play. We can always stream to disk and stuff like that. But we really haven't gotten to that kind of a point with our entity system, I don't think, because, like I said, there's just a ton of fat in there right now that I would like to remove, and it's not that difficult for me to go ahead and remove it. So what I'm going to do is I'm going to start by sort of talking about where we're at with that memory layout and what I'd like to do to fix it and why. So it looks like somehow I got my shell closed. There we go. Let's get that back up here. I guess I just clicked on remedy, so that's why it was never open. I didn't close it, I just never opened it. So if we take a look at Handmade Hero, the policy we've been following so far is that we aren't working on the entity system. That's been the policy I've been following so far. So what I did was every entity is just a bag of garbage. You can throw anything in there you want. Every entity has everything. There's no design to it, and it's fine. And that's very intentional, because the last thing I think you want to do, and I've said this many times, the last thing you want to do when you're designing a system is pick a design up front. It's the absolute worst thing you could ever do, is decide, I'm going to use an entity component system. Before you've even written any of your game, you make this choice. I find that to be an absolutely terrible way to design code, and the reason is because you're deciding a solution before you have seen the problems, right? And solutions to problems that don't exist aren't solutions at all. They're just wasted work. And so what I like to do instead is defer my solutions till I actually have my problems. And in this case, what that means is everything in the game is just a big bag of crap, right? In this case, until we actually have some idea of what we want to do with it, right? And so this particular situation is starting to bring up a actual coherent problem I can talk about solving, and I can see how I would want to solve it. And so now I think is a good time to add a capability to our entity system that does address something that's happening in there that I would like to solve and can think of a concrete way to solve it. And that thing is that I would like to start adding very large elements to our entity system, like these, and when they are placed in here, they make the entities too big, right? So if I look at how much space was being taken up, by this ground cover, for example, when we look inside the memory view, and I did this before, we see how much space that's taking up relative to everything else, right? You can just kind of see how big that is. If I were to change it so that we don't have storage for the ground cover, just the ground cover, never mind the lighting point state, which is also large, or any of these other sorts of things, if I run that and reduce the memory footprint by that much, you can see this decreased dramatically just from that one member, right? Like, if we imagined that our previous size was like a bound on how big the world could be, just removing that one member from our entities would have allowed the world to be twice as large. And so that's just, to give you an idea of what I'm talking about. And that's going to be true of everything that we potentially add here, right? There's so many different pieces of information that we might want to start covering, and if you imagine all sorts of potentially fairly complicated things that are listed here, like pathfinding information and lighting and ground cover, decals, footprints, who knows what. Those sorts of things all add up, and when not every entity is using them and you're storing the entire world with perhaps tens or even hundreds of thousands of entities in it, that multiplier is just too high. So the question is, what do we actually want to do to address this problem? Well, this first part of the problem, like I said, shows me an obvious way that I can address it, because I have a concrete problem and I can design a concrete solution. The concrete problem is that during actual visibility. So when the entity's on the screen. Lighting and ground cover are visual effects that need to be represented, and I would like them to not have to be recomputed every frame, right? I would like to be able to do things like track the ground cover or the lighting, and I'd like them to be stable across frames and remember information across frames that's relevant to the gameplay. Perhaps even down to relatively specific things that happen, such as how grass gets trampled down or how the lighting is propagated throughout the scene. But once I move out of an active region, I don't necessarily need to remember those things. If the user is actively looking at a piece of terrain and I don't store exactly how that terrain got modified, they will see the change occur, right? Like, they would notice a difference if they're looking at it. But if something goes outside of their view and they go 3 or 4 rooms away and then they come back to it, all that they really will remember is roughly what the state of that area was, right? Was this thing burned? Was this thing lit? Whatever, right? But they won't necessarily remember the exact state of things. So I can afford to potentially forget really specific things, like was this specific piece of grass in this specific place, right? And so what I'd like to do is introduce sort of a second level cache. And I talked about this again when I was talking about adding it 2 weeks ago. And this is what I'd like to add now. A second level cache for things that are purely cosmetic, which can sort of be lossily remembered. So I just kind of need to remember how much grass roughly was there on this patch with maybe like a single scalar. That needs to get remembered. But what I don't need to remember is the exact arrangement of the grass on this patch. That I can just get rid of and regenerate it later when this thing comes back into view. And so I'm looking at a way of sort of taking the ground cover field or the lighting field. I'm looking at ways to essentially compress that down and store it in a small permanent way when I need to, and then be able to decompress it later. Now, because of this sort of, how should I say this? Whilst thinking about this, so while that's kind of in your brain, right, and you're thinking it to yourself about the ramifications of making such a change, well, I've always, since the very beginning of the entity system, suggested that we would probably have something like this, where we compress entities down into something that only remembers the things they actually use. And these are sort of related in a sense, right? Meaning storing sort of lossy versions of certain visual elements is very similar to compressing entities down based on only what we actually care about remembering. And so, for example, if you imagine an entity that doesn't have hit points, well, we don't really need to store hit points for that entity, right? And so these two things are actually kind of, they feel the same, right? These two things feel very similar in that if you have a set of entities that want to be compressed based on usage and also lossy storage that might want to happen, it sort of gets me thinking about alternative ways of dealing with our entities in general. And let me discuss that with sort of give you what I'm thinking. And I hadn't really thought of this when we first started typing in entities, so it wasn't something I was looking at. Again, it's something that kind of comes organically out of how you end up building the system. So consider this. We want to be able to work with entities in sort of what I would call their full form. And that is something that looks a lot like this sort of bloated entity structure that we're talking about here. Bloated in the sense that it has a ton of stuff in it that we don't actually need in a lot of cases, but it's very easy to work with like that. Why is it very easy to work with like that? Well, it is because there's no restrictions on what we can do, right? Any piece of code can just write to any piece of the entity and add capabilities to it willy-nilly, right? there's no hard constraints on what an entity is or isn't. And so it gives us complete flexibility. And furthermore, it gives us that complete flexibility with no runtime costs at all at the moment, right? For the routines that are actually operating on it. Because we don't have to do things like searching a list of properties to find if it has one that we're talking about. We don't need to allocate properties on the fly to attach new properties to things. None of that has to happen in our system. And so the runtime cost that we are paying right now is actually just strictly a memory cost. It's a memory bandwidth cost. So instead of having a computational cost and a memory bandwidth cost that's just less, of looking through things like, say, an entity component system might do, or some kind of a system that had entity properties attached to it, or suffering the restrictions that come from a thing where entities are sort of fixed in their conceptualization, and like this entity is this kind of monster and only stores the information for that kind of monster, so it can never get any other things applied to it, right? Instead of having that Procrustean restriction or the restriction of having to have all of this busy work where things are finding, or, you know, on every piece of, on every single time anything happens with the entity, we sort of have the best of both worlds here, and we pay the cost only at the time when we actually need to consider paging memory around, right? Because it's like the cache cost is the only cost we're paying. And so far it's unclear that we're really paying much of that cost, right? And so the question is it perhaps possible to retain the usage of the bloated entity structure such that we really can keep using it as arbitrarily and as flexibly as we want, perhaps even going further and allowing sort of arbitrary size lists in here and stuff too, even, right? Like, perhaps even more bloated than it already is. Can we do something that supports that and potentially gets rid of the memory bandwidth costs of packing and unpacking storage for these sorts of things, and or the bloated memory footprint cost of just storing them at all, right? And what I started to realize was that, well, here's what we're doing. We have a begin sim call, and if you remember the way the begin sim call works, is it goes through each of the world sort of buckets. We have what essentially amounts to a sparse voxel storage for our world, right? All of our entities are just kind of binned based on where they're located, and when you go to simulate a particular region of the world, what you're doing is you're gathering all of the buckets that might contribute to that region of the world, right? That's all we're doing fundamentally. And so when we call this begin sim call here, what we do is inside begin world change, we sort of unpack all of our entities into like an active set. And we set this up because we thought someday we might want to do that unpacking in a real sense. But right now, all we do is actually... Let me actually go and grab that for you. Here you go. We thought that someday we might actually want to do that decompression. So we do actually have a step here where we're like, hey, let's actually unpack the entities that are involved. And I believe we do that right here. Right, we take this destination, we say, you know, this should really be a decompression step, and we copy it, right? And then when we do an end world change, we copy it back, right? So you can see us doing that here. And we have a little bit of packing that we do, but a very little bit, right? It doesn't really, there's very little to it. It's really just that, right? So now the question is, you know, if we're paying this cost here to like pack and unpack entities, we have to ask ourselves, from one frame to the next, how much difference do you think there is in terms of entities that we've used, like that we unpacked last frame, and the entities we need to unpack this frame, right? And the chances are it's almost exactly the same. As the user moves, right, a few new entities might page in on the side, like maybe 5 to 10% of our entities may page in on the side, and maybe 5 to 10% of our entities will page out on the other side, right? But like, other than that, there's really very little going on in terms of the packing and unpacking. We literally packed all of our entities last frame up, only to unpack them all again this frame. So this got me thinking, well, why don't, instead of us thinking of simulation as unpacking all of our entities, simulating them, and repacking them, why don't we just assume instead that the simulation just works on unpacked entities? And all it really does is ask the world storage to make sure that any entities it's going to touch are unpacked. But if those were already unpacked from last frame, they just stay unpacked. That system could then pack only those things that are no longer being used by the simulation and unpack ones that are, but essentially act as a rolling cache that doesn't require any packing or unpacking at all most of the time. Does that make sense what I'm saying? I hope it does. But we're going to go ahead and do this over the next few weeks. And so hopefully, if it's not clear what I'm saying, you'll get a couple chances to sort of see what I'm talking about here. And so fundamentally, there's a couple phases in which I want to, sort of make this change take place. And what I'd like to do here is say, okay, let's start by assuming that this is actually just a reference table. So when we say begin world change, what I'd like to do is say that the sim region entities here, this thing, right here, right? So that, where we sort of say, look, we've got some number of entities that we're going to unpack, and we need to store them in here. Excuse me. What I want to do is make that set of entities there, I want this to be a reference table, basically. So instead of referring to entities directly, these will just be like pointers to entities or something like that, right? And furthermore, if you look at the way we're doing things right now, we've got this entity pointer here in our entity hash. What it makes me think is, well, maybe actually the entity hash could just be the only thing there is. So meaning this doesn't actually have to be there anymore, and we just walk the entity hash to do stuff, right? Now, why do I want that? Well, I want that because if we just start using entity pointers everywhere and don't ever look at some like compact array, that implies that we could just point into a cache held by the world for each entity that we know is stable up until the time when we stop our simulation for this block, right? So we can start the sim, use pointers into the world's sort of L2 cache of unpacked entities, simulate them all, be done, tell the world now is a good time to pack any entities that you think need to be to stay under particular memory limits for how many unpacked entities we keep around, for example. And off we go. Right? Make sense? So that's really what I'm thinking. And so the first thing I want to do, again, I'm just going to start to explore that change. The first thing I'd like to do is change this entity structure to be something that will generate an error everywhere it's used. And what that's going to allow me to do is just inspect my code to see what I think the impact of this change will be without ever actually doing any code in the first place, right? So what we can see here is there's a connect entity pointers call, and what that's doing is really like sort of swizzling up the, swizzling is the wrong word. it's connecting up entities to other entities in the system, right? And I think that that is something that will probably have to always happen when we at the begin and ending of simulation. And the reason for that is those pointers that we're using, if we, maybe we will stop using pointers altogether and we'll just always use hashes to connect the thing. But regardless, because when we do a pack on things, we can't necessarily know who needs to be updated to not have a pointer. We don't want pointers sitting around inside we don't want pointers from entities to other entities generally to persist outside of the simulation, right? So when we start the sim, inside there you can have entities pointing to entities all you want, but when you finish, you want to get rid of those, right? Now again, I'm not really sure that we want that in the first place, because I'm not sure we really want to. I'm not sure we really need entities pointing to other entities instead of just using a hash by like their ID. So I'm not sure we really need to do that, and we may want to look at just removing that and using the hash instead. That's sort of a separate issue, right? But anyway, so that's fine. We could just loop over the hash there or whatever. Like we got plenty of there's really nothing weird going on there. What by the way is this entity hash occupancy used for? You know what? Hold on one second. I want to see what that's used for before I do any more of this. I don't really remember what we're doing with that. So it looks like that is literally just to speed up clearing so that we can just clear that field. That's what it looks like. So I'm assuming we literally just added that to speed up this clear. So that instead of having to clear all the entities, we just cleared instead of having to clear the entire entity hash table, we just cleared the occupancy table. I think. I mean, looking at it, that's the only thing I can think that would be doing, right? I mean, I don't see anything else that's good for. So we don't really have to care about that. That's totally fine, and would not be affected by this change at all, really. Okay. Just wanted to make sure I knew what we were doing there. Looks like that's just for accelerating that clear. All right, so this is us just allocating the array. Again, that's nothing. And this is us unpacking into the array. Again, totally fine. Here's us packing back up. Here's us adding an entity. Again, none of these things really would be implicated there, I don't think. This is us testing all of the entities in the system to look for a camera. Here's us looking for traversables. And again, we want to do these by spatial queries anyway, so again, this is really totally fine. Yeah, so like all of this stuff, I would say, all of this stuff, I would say, is really not a problem. So I think this is pretty trivial, right? I think we could pretty much just get rid of this as something that anyone ever used, right? And we could pretty easily move it out into the world structures. So if we go into the world structures here, right, we can see here's the world. And here's where everything is stored. It's in this chunk hash here. And this, I don't know what we're going to do with. This is just for maps and stuff, so that we can ignore for now. That'll be something we look at a little bit later. But if you imagine it here inside this world part here, we had something that was literally like an entity cache. So in here we've got like this. And so we've got this unpacked entity cache, and the unpacked entity cache just kind of tells us like who's who and why and where and what's going on. For unpacked entities, we would have essentially the same thing that we have inside the sim region, right? This would be there. And the difference is this would just persist from frame to frame, and when you went to like, you know, unpack things or you know, as you were unpacking things, this would keep track of who was unpacked and who wasn't, and it wouldn't have to redo work that was already done, right? So if you unpack a bunch of things on frame 0, on frame 1, you then try to unpack mostly the same things. You don't do any work. You just get pointers back into here of the already unpacked entities. And that way, in fact, I'm trying to think. So, you know, in this world chunk here, where we've got this world entity block, right? I'm not sure why this says if a pointer would be better here, because it is a pointer. I think we previously did that, but we don't anymore. So the answer is we are doing that. In here, in this world chunk, we would just say, oh, you know, we just need some way of saying whether this thing is in the expanded set or not, right? And so, like, maybe something like this. You know what I'm saying? So we have something like this where we've got like an unpacked world chunk. And in here we would say like, all right, we've got an entity array that's, you know, keeping track of what's happening inside, you know, the unpacked version of the world chunk. And then what we can have is sort of the same thing, right? And this one can probably be significantly smaller, right? Because there's not that many world chunks that are unpacked anyway. So you're not going to have to look through a whole heck of a lot of them, unlike this, which could have lots and lots of chunks in them. Like this has like thousands of chunks potentially, or even maybe tens of thousands. This has 100 or something, right? And so you really don't have to make this particularly large in order to avoid long chains. So if we have an unpack hash there, and we imagine something like this, the only thing that makes me nervous about this at all is just the fact that I don't like having to have entity headroom in every one of these entity arrays. And so that part is maybe a little less good than it should be, maybe. And so I think, you know, it's hard for me to say, but I think the way I would like to handle this, in fact, yeah, I'm pretty sure. So if you think about what happens here, right, we've got these different world chunks. And when we go to pack a world chunk back up, what we really want to do is pack all the entities that might have moved into that world chunk. So storing that like this isn't really what I want, right? All I really needed to do was store whether it was unpacked or not. So honestly, I think maybe it's okay to just say, was this thing unpacked or not, right? So in here, you know, we've got this thing where we've got the XYZ coordinates for it, and then we've got some additional information. This is already unbalanced, so if you look at how this is structured, right, you really want it to look like this anyway. There's already effectively an unbalance here. This is 8, we've got 8, there's 8, and 4, right? So it's already a little unaligned. I don't feel too bad of just having, at least at the moment, it can just be a B32, but we could make this flags if we wanted to in the future. Just say, is it unpacked or not? Right? Like, does it exist in the unpacked set or not? I think that might be better, and then we could say there's a giant list of entities in here that we pack and unpack into, and then that's like it, right? And that's all we do. I think that's probably best. Something like that. And so if we do something more like that, I think then we're in much better shape. And we don't really have to do any additional work, I don't think. When it asks us to unpack a chunk, all we do is we do exactly what we were doing before, but now instead of always adding the things from the chunk to the entity array, we instead look at the unpacked value here, and if it's already unpacked, we just don't do anything. Right? And that's it. Later, when we go to pack up, all we do is say, if we were going to pack a particular chunk that we've determined isn't being used anymore, well, all we really have to do there is loop through the entity array, packing up entities into that chunk that belong in the chunk, and marking them as no longer in our unpacked entity set. But that's it, really. And I think that works pretty well, right? I think that's good. I think we're good to go at that point. The only thing that I'm not sure about how we would do, and maybe I'll just start typing in the actual routines and see where it leads us. But the only thing that I'm not sure about here is I don't know how to detect which world chunks should now be packed, right? And so that's why I kind of think we need some sort of a list, like an LRU sort of a list here, that just says, here are the chunks that I did unpack, and now you are going to have to pack them back up again at some point, right? And that part I don't really have a coherent idea for. You can think about what the code's going to be in your head, right? So you're going to do a sim step, and maybe like at the end of every frame, who knows, or maybe at the end of every sim step, you're just going to make a call that's like, hey, pack the least recently used chunks as necessary, right? So if you've got a bunch of world chunks sitting around that haven't been used in several frames, pack them back up, because they're probably not needed anymore. And the problem is, how do we know, right? It's pretty easy for us to store in the world chunk. Like, instead of this unpacked value, we could store a, like a timestamp. Like, when was the last unpack of this thing? That's pretty easy for us to do, but what's not so easy for us to do is to know, without looping through literally all of the world chunks in the system, who's the least. And so we kind of need some secondary, right, you see what I'm saying? We need some kind of secondary structure here, and maybe we just store like another list of that or something. That we cycle through, I don't know. And like I say, I really just don't have a solid idea for exactly how that should work. So let's start by just doing the initial unpack stuff as if we knew. So I'm just going to pretend that I can loop over those at some point and figure it out. And then we can, after I'm done with that change, figure out how the heck we're going to do it, right? We'll after we get everything else done, which is plenty of work to do for today, then after all that's said and done, I don't know, tomorrow or sometime, then we can start to talk about, all right, how do we actually know which world chunks get repacked, right? How do we know who's the ones to do? And we don't have to do that right away. We could just pack everybody back up, right? As a start. But yeah. All right. So let's see here. You know what else? Unpacked may be superfluous because if first block is 0, then you are unpacked, right? So we may not even need this. I'm going to get rid of that for a second just to see if that's true, because I think it might be. So we'll see. All right, so anyway, let's go ahead and make this happen if we can, and go from there. All right. So when we're doing connect entity pointers, again, for the short term, what I'm going to do is I'm just going to step through the entity hash here and use that as the way we loop over all entities, if that makes sense. So in here where we do connect entity pointers and we call that on the sim region, I'm going to introduce basically a helper here. And that helper is going to be something that allows me to sort of easily iterate over all entities. So something like this, right? And I would say like iterate all entities. I pass the sim region in, and then I would say something like this. Right? So basically just a thing that allows me to loop over all of the entities. And then this here is the only part I think I would have to actually replace, right? Something like that. Since this is a thing that essentially only loops over a pointer, we could probably also just do this, right? That's probably fine too. And so in the interest of keeping it simple, maybe we'll just say that. And that way we can basically turn all loops into something that looks like this. What I'm going to do ahead of time here is actually just sort of define this as a stub so that I can compile and see if everything works. And then we can kind of go from there. So we'd have an entity iterator that gets returned from iterate all entities. That needs to take the sim region. And we would also have an advance call, which takes this iterator. And that would really be it. That's the entirety of it. And so I think if I then compile, I'm hoping that that will give me an easy way to replace the routines I was using with a utility function, right? So here is an example of, excuse me. Sorry, not that one. Ooh, create entity, don't care about right now. So here is another example of something that loops over all of them, right? And so again, I'm just going to do the same thing. This time we wanted something called test entity, so I'm just going to make it test entity, but otherwise it's exactly the same. Here is another one, right? And so we'll go ahead and do that. Same exact thing. And again, a lot of these want to use a spatial partition, so these will get, a lot of these will get replaced anyway. Again, which is good, because it means that we really don't care how inefficient this is, because we're not really going to rely on this in the final product anyway. So this is just a stopgap measure, and we don't have to be too concerned about that. All right. So yeah. Looks good to me. Let's clean up the compilers from that, and then look at the places that we can't replace with that particular thing. So there, and there. This is just a different word. It's not called sim region. It's just called region. I didn't really mean to recompile there, but I did. Oh well. Did we not replace this? Guess we didn't get that far. I don't know what the sim region is in this case. Oh, it's just called sim region, so that's pretty easy. And looks like one more. Okay, so that allows all of our iterations to work, and we can just implement this when we're ready. And so now really what we got to look for is the rest of this stuff. I think the way I'd like to do this now is just by actually not doing anything other than moving exactly the thing that we previously had into the world code. So if that makes sense, like, I'm not actually going to implement any of the stuff we talked about. I'm just going to change the location of the way it's currently working to work inside the world struct. That's all. And then we will progressively sort of add features to that until it becomes what I was sort of talking about. All right, so in here we're going to need something that does this, right? Like, obviously that needs to happen because we need space to store this stuff, and so we can have that happen as we go. In here where we're doing sort of this dest bit here, this unpack that's occurring right here, you can sort of see the add entity to hash is something that wants to probably remain inside the sim region side of things, and the dest p plus equals chunk delta stuff, that has to probably keep happening too, I would suggest, because every frame, the entities have to sort of be centered around our simulation origin. So I feel like that part is going to have to persist, right? Like, that part's not really going to... that part we have to always do, right? So we have to look at that. These two things as always having happening. This part... Yeah, all of this stuff... This all looks like stuff that would normally happen, right? So here where we do the remove world chunk, right? We're pulling this chunk off. We're doing all the work to it. What I can't quite understand here, though, is where the copy happens. Oh, no, I can't. It's right there. Duh. We already looked at it. So there it is. So again, looking at this stuff here, this is all stuff that's really sim region related, but everything above it sort of isn't. So I feel like a lot of this stuff... Let me look at that add entity to hash. Yeah. So I feel like if we kind of group this stuff together here, we can kind of see what we're dealing with, right? In terms of the stuff that's getting unpacked. That seems like all of it. And then this stuff just has to happen on everybody anyway. So that's the tack I'm going to take. Again, this is fairly subtle code, so you can see I'm being careful. Trying to think it through relatively carefully here to the extent I can. And so really what I'm looking at is this entire preamble really all the way down through here. Is I think what I'm looking for, right? That's pretty deep. A lot of loops there. A lot of loops, a lot of ifs. So that's the like three-dimensional loop over everything, removing those in there. And similarly, the add to free list part of things. So after this chunk is removed, right? Like when we grab it out here, we do want to do this part as well. I'm going to try and get all of this stuff out here. I'm not sure what the... this was, I think, just to guard against the entity count being too high. But I think... that should be fine. And so coming through here, looking at what's happening, this is going to be a for I loop here over all the entities in the system, and then this stuff is going to happen as before, so connect entity pointers. And what I would say is that if you look at how this is actually happening here, since all of the entities, you know, if I look at connect entity pointers, in fact, if I look at where we're calling connect entity pointers, you can see that it's sort of just a one-off. I think I might make that just part of this routine directly. So I want to get this sort of out of here. And in sim region where that happens, I think I want to just make that be something that happens, right? Because I think we want to do this all in one loop now, if that makes sense. So I'm going to get rid of this. That's going to go away. And in here where we sort of do this stuff, I'm going to say, let's do this all in one pass, right? Oh, well, but adding to the hash has to happen before we can do this, sadly. So it still will be two passes, it looks like. That's too bad. At least I think it's too bad. So this is a two-pass, which I don't love. We could maybe look at that a little bit. And to me, that sort of argues, again, this, like, traversable reference nonsense. I feel like maybe those just need to not be pointers anymore anyway, and they need to go through the hash table. Because, again, you can see, like, I have to do a second loop because I need to do one loop to fill the hash table, and you do another loop to connect them up. It just seems kind of bad, especially because, like... we don't even know if anyone's going to need these, right? We're sort of assuming that we're saving time by converting those ID reference by ID to reference by pointer, but we don't even really know that we are, and so I suspect that this might just be a waste of time. And that's pretty high on my list of things to look at after we're done. I'd like to make sure that we do that the right way, because I think probably this is the wrong way. All right. So I think everything we need is right here. I think that's all we needed to really do. So if I go ahead and sort of change dest to be entity here, and I think that's just true everywhere, right? Because all this code came from the same interior, so it should just be dest everywhere. It wasn't two different parts. I think that was the same part. All this looks same to me. So I think that's all good. So we've got the this loop here, and I'm hoping maybe we'll just get rid of this loop so we can look at that a little bit later on. But for now, it basically looks like this. And so what we need to do inside the world struct itself, right, is this call here. So we've got this happens on startup, but this call here, where I'm going to like unpack world region, maybe I'll call this ensure region is unpacked, something like that. That's going to pass in the like min chunk, max chunk positions that you're trying to use, like so. And then obviously we need the worlds that you're unpacking. And then when we have that map into sim space call with the sim region, that part I don't think I want to actually pass the sim region in here for any particular reason, because we don't need it anymore. So what I'd like to do is that map into sim space. When you look at what that's actually doing, you can see that it's just doing a subtract on the origin, right? So what I'd rather do is I'd rather just have that origin, this part here, I'd rather just have that be something that gets passed in, right? And so when we're doing that unsure region is unpacked, I feel like this allows us to essentially take that map into sim space bit there and just make that happen directly. So on here we would just say, all right, the chunk position that you're talking about, we're just gonna do that subtraction in line here, and off we go, right? Now, the other thing we could consider is again, when we're doing that chunk delta bit here, that's the part that we need to add to these entities, right, in order to get them centered properly. Well, you know what? Now I look at it, okay, so we don't really want to do that. We don't really want to do that, do we? Because well, yeah, I don't know. So the problem that we have here is the world position of entities it's just a vector, right? And it's stored relative to the chunk when it's packed, and but it's considered relative to the sim origin when it's not. And so I'm not sure how to, that's the one piece of information that's a little bit ambiguous as to how you would handle it here, right? Because since when you unpack this, the sim region itself is not going to know whether someone's position has been adjusted yet, right? So it doesn't really know what to do. It doesn't really know what to do about that. I mean, if we're more explicit about this, then what you'd have to do is something more like this. So if you look at kind of what has to happen, if we were to do like a literal translation of what would go on, then you can kind of see it's a bit nasty. If the entity was already unpacked, it had a previous simulation center that it was stored around, and we need to update it to the new simulation center because the simulation center may have moved, right? But if this entity was unpacked fresh, then it was stored around its chunk, in which case the update it actually needs is the difference between the chunk center and the simulation center. And that's this chunk delta, right? And that's like really kind of subtle and error prone. You know? It just doesn't seem it just doesn't seem like a good idea to me. So I kind of feel like, as much as it's not my favorite thing in the world, it seems like it kind of argues for the entities to generally look let's see here. You know, it kind of wants them to know what their origin was. You know what I mean? Is like the sort of least error prone way to do that is anytime I update an entity, I just store like what was its P around, and then when you go to start using it at the start of simulation, you just say, well, I need it to be centered around this. So is it or isn't it? Right? And I guess I don't know. Is that a good idea? It seems very wasteful because you only really needed one bit to tell you whether this thing was stored relative to the previous simulation center, which you could store as well. So let's do this. Here's what I'm going to say. And I don't know if this is good or bad, but it sort of seems good. Here's what I'm going to say. I'm going to say there's an unpack origin. Right? And I'm going to say that this doesn't happen here ever. In fact, I kind of like this. I'm happy with this. So what we're going to do is we're going to sort of create a origin update, which is like when Electronic Arts system downloads updates. We're going to create an origin update, and that's going to be the update that's necessary to take the location of the new origin and move us from our old origin to there, right? So if we said we're going to go from the previous unpack origin to the new origin, that gives us the de-unpack origin, right? Like, what's the delta between those two? And then I can just go ahead and set the world unpack origin to be the new origin. And then when we go through the entities, what we can do is during unpack of entities, we can just add the chunk delta like we were going to, right? So basically, we know we're unpacking around the unpack origin, so it looks like that. But for any entity that existed a priori, right? So the one that was there beforehand, what I can do is first loop over those and update those. So I'll say, all right, entity index from 0 to however many we have just do that one piece of bookkeeping, and off we go. So in here we would say that the unpacked entities entity index plus equals dunpack origin, and there we go. That's actually much cleaner. I like that a lot better. So we do one pass over the entities to adjust them to the new location, and then we do it. Now, again, I don't love having to make all these additional passes over to the entities. It's less good, and we could save time by not doing that. So I don't love it. It makes me think that probably we want, you know, this stuff to be done sort of in a welded way. Like this stuff should probably be handled in here, and this stuff cached as well. You know, and it seems like since we're doing that loop over the entities there, you know, why wouldn't we just update the hash table and all this other stuff, you know, there? And I mean, I think we just should, right? And so if you look at what would happen, this call can just happen inside this loop and inside this loop, right? So we can have two different calls to that same bit of logic that's happening here to make this stuff work. That can just could have just happened in here. And so, you know, it kind of suggests to me that we, I don't know, it's a little tangled, but if we did take the sim region here, then this piece of code could be called from both places. You know what I'm saying to you? So you can see why this is a lot more efficient, and it makes me think I kind of want to structure it this way. It's exactly the same code, it just doesn't need so many loops, which is generally means it'd be better. And so then in here, we just do the same thing. The entity gets registered. In either case. That gets us out of this business entirely, and since I want this to go away, that would just have one clean pass where you get everybody registered as you sweep through them the first time. That just seems better. So even though it's a little tangled, I think I prefer it for now, and we can untangle it by pulling the sim region apart into two pieces if we really wanted to. I don't think I do want to, but you know, we could, right? It's certainly possible to do so. Let me take a look at where we're at on compilers here. This just needs to be placed out here in the create world call, like so. This no clear doesn't actually need to be a no clear. We can totally clear it now because we just allocate the thing once. And these have different names. That's max unpacked entity count. That's unpacked entity count and unpacked entities. And this arena is like this thing, which is, you know, wherever we're storing the rest of our world garbage, it's there. All right, so yeah, we got a bunch more work to do here, but I think this is on the right track for doing the isolation that I wanted. This right here needs to be off of the world. But otherwise, that looks fine. Keep forgetting that's called Unpacked. And so I think, yeah, that just leaves us with these two operations that we were doing. And so really the create entity call would be exactly the same as before. That's pretty easy to handle. Both create entity and delete entity are just fine there. And so if the sim region, you know, it's got the world pointer in it. And so really what these are is they're just thunks to the world code, because the world code is the thing that would really be handling this. And so I think what you want there is just, in this case, it really doesn't need to do any, I mean, it doesn't, this is really a call on an entity. It doesn't need a region, and probably never will, because it's just going to make sure that it's marked as deleted, but we're not actually going to do anything with it. So really, this is the only call that we're talking about here. And so it's really just this part that we would be forwarding. So what I'm going to do here is in the world code, I'm going to have an internal call here, which is like create entity. And that's going to be effectively the same thing, but it's going to just take the world, actually, and probably nothing else. So it's going to do this part. Like that. And then it's going to return that result. And so this part here is just a thunk. It's going to say, I'm getting my entity from the world that backs me. That'd be a stretch these days. A world that backs you. So once we get one of those, then we proceed to assign it an ID, which is, and then add it to the hash, and that stuff is done on the actual sim region, right? So I think that probably takes care of all of this. That null entity should be moved to like that. It's just going to be, oops, moved to the world. And these just get changed to their unpacked versions, because you always add unpacked and then pack. You don't add packed and then unpack, right? We add to the unpacked set, and then it gets packed down later on. Okay. So now, and I guess this is fine like that too. I'm going to go ahead and make that be just a thing that we hang off of ourselves. And there we go. So that should be fine. And this is all off the world. That doesn't matter. This is the end world change stuff, and so that's the last thing that we should have to do, I think. And it is. So now we have to deal with this situation here. And so if you look at what's happening, first we have a map into chunk space, and sort of doing the storage of this stuff. With the exception of the packed traversable reference, which kind of has to be done every frame, the other stuff is stuff that we only do when we actually pack something, right? And so if you look, I don't know what this stuff was for. Oh, this was for us testing whether things moved, I guess. This is going to be out of date now, so I'm going to get rid of that because we would probably have to write that again later if we actually wanted it. So what we want to do now is when we actually end, when we sort of like, you know, repack entities as necessary or something like that. You know what I mean? We're just going to basically call this and say, hey, like, we're going to repack stuff now, by the way, just so you know, do whatever you want. And this here, I should time both of these functions, by the way, because they are doing a lot of work. So this guy should get one of those as well. So when we do ensure region is unpacked, the corresponding thing is repack entities as necessary. And that's just going to pack stuff up to ensure that we don't waste space. Now, again, the thing that I said that's a little bit squinky is these packed traversable reference nonsenses here. And again, looking at one of those things, I'm just not sure I like this stuff anyway. It just looks crappy in general. Like, if we have IDs, then, like, just use the ID. Right? And so I just kind of feel like we should just use the ID everywhere instead. And I feel like that just makes this code work better. And so I kind of want to do that and just say that those traversable references just have to be by index now, because there's already, a call that gets that for you. And so I don't feel like we really need to do that. It just seems stupid. So I may just also say that we're going to get rid of that. I'm not going to literally get rid of it right now. And the reason for that is just because I don't want to introduce more changes than I need to in one step. So I'm going to let it sit just for the briefest moment, and then we're going to get rid of it. So what I want to do now is, instead of judiciously repacking, we're just going to repack everything, right? So this stuff, at the moment, and world change is just going to call repack entities as necessary on the world, and all of this stuff is still going to happen because all of it can happen, right? So what we're going to do is we're going to go through all of the entities that still exist in the world, like this. Actually, that can stay. And as we loop through them, we are going to put them away exactly the way that we used to put them away. And then what we're going to do is we're going to set our entity count to 0. And that's that, right? So I think that's really all we need to do. That can go away. And hopefully this will sort of work. We may have a little bit of debugging to do, but hopefully it won't be a huge deal. When we're doing this remap here, to remap one of the entity's positions into chunk space based on an origin, again, I sort of, presciently, although we knew what the code was, so it wasn't prescient. That's what compression-oriented programming lets you do, is appear like you know everything when you do your design, because you do. I stored the unpack origin so we can unpack and repack based on that origin and be correct, right? Because that is exactly what we would expect to have happen here. When we're doing this pack traversable reference stuff, we need to know what the sim region is, because we need to... Actually, do we? Why? When you do pack entity reference, where is the sim region used? So if the... What is this about? So if this thing doesn't have a pointer, but it does store an ID, then it says if I get a hashed pointer, I don't actually know what get hash from ID does. Let's just quickly take a look at that. So it's saying if there was a lane for this thing? What? I don't quite understand what this was meant to do. We're basically trying to zero out a reference to something, and we're trying to zero it out in the circumstance... Oh, I see what this is trying to do. It's trying to say if someone zeroed out the pointer, they're trying to tell us that. Yeah, okay, so you can see this just sucks. So, yeah, we definitely don't want this, right? It's just bad, because look at all this garbage you have to go through, because if you just set the index to 0 instead, setting the pointer to 0 here, we have to do this extra work to determine that that meant you were clearing it and not that it was a reference to something that isn't unpacked in the sim region right now, right? Yeah, so that's just stupid. I don't like anything about that at all. That's just bad. That's just bad in general. So that, I mean, this is just further reason why we want to get rid of this code. So sure, for now, what we're gonna do is, let's just say that the region gets passed as 0, and we'll deal with the bugs from that at the moment. And then we're just gonna get rid of this. This is gonna go away completely, because I don't like it, and it's bad. All right. Let's see what else we got here. this is not found, packed traversable reference, so we'll just kind of make it found here temporarily. All right. And that just leaves us with this, which is a really simple thing we had to implement here where you loop over the hash table, which is really pretty straightforward. But let's go ahead and implement that. So really all we need here is just some way of knowing what we were actually iterating over. And if you look at the way this works, the entity hash table is an internally chained hash table. So just looping over it is sufficient, as far as I can tell, to visit all of the entities. Because if you look inside the entity structure itself, we don't have like a hidden pointer there that chains these things, as far as I can tell, right? There isn't like a entity star. Yeah, so there is no way to chain these together. So basically, looping over the hash table, all we're going to need for storage here is a hash index. And so when you do iterate all entities, all we have to do here is say, well, I guess we need one more thing, which is the pointer of the sim region. Although I suppose we don't really even need that per se. I mean, we could just do this. Right? And maybe that makes more sense. Does it? I don't know. All right, fine. Let's just say it's that. I don't know. I don't want to think about it too hard because I don't really care about this piece of the code. All right, so we're going to make a iterator here. And this iterator needs to store the sim region. It needs to store the entity that we're pointing at. And it needs to store the hash index that we're at, right? And so in each one of these cases, we sort of need a little helper function here. And we'll talk about that in a second. But effectively what we're doing, don't ask me why these didn't have internal before them. Just because they didn't, I guess. In here, we're doing the same thing. We're just going to bump the hash index here, right? And so in each of these cases, what we need to do is scan the hash table for the first time that we see one of these one of the hash table slots filled with an actual pointer. And so we need like find next entity or something like that, right? That's going to take one of these things and find it. So we first start it to 0, then we say find next entity, and we say, you know, go to town. Here we would increment it, right, and then say find next entity, go to town. I think that's all we really need to do. Here I would like to assert that there is one, because you should never call this function if with an invalid iterator. I just want that to be an error for now. And so here where we do find next entity, we just need to scan through the hash table looking for a valid one, right? I'm also going to start out by making this equal to 0 just in case. Well, no, you know what? No, I'm not. I'm going to do that actually here. So we'll start by assuming that we couldn't find one. We're then going to loop through all of these by saying start at the hash index that we're on, go until the sim region, what was it? Entity hash. Go until the end of that table looking for one, and then, well, we don't have to do return anything, and then return. So since we know this already starts here, and this is the actual thing that we want to increment, I can also just instead turn this into a while loop that kind of just looks more like this, right? And so this way we can just loop through these, incrementing as we go. And all we have to do is say, look, if the entity hash that's at this location actually contains something, we want to stop, right? And furthermore, this pointer here is the actual pointer we want. So we can say this. And remember it, which is what we want as well. I think that's all we really need to do to iterate over all of these, but we can double check that by stepping through it in Debugger. Make sure we didn't forget something. Okay, that's supposed to be an arrow, because this is a pointer. So I'm not sure why I wrote it as a dot. That's just the way it goes sometimes. And also, obviously, this needs to return the thing that we actually made. Okay. I think that's everything. This is the actual hash index of the iterator that we're incrementing there. And off we go. Yes. So now it comes down to debugging. We need to actually make this stuff work. So let's get started on that. I probably want to make this easier on myself. I'm going to go turn this into debug mode so that we don't have to do too much work to decrypt what Visual Studio, well, what the PDB is telling us. So let's go ahead and get that going. Here where we do, let's see where we are in the call stack first of all, just so we have some idea what's going on. You can see in here we're in begin sim, so we're looking for our entity this way. Looks like maybe we didn't, when we did our unpack, we didn't like hash everything that we should have hashed or something, right? So let's just take a look at what's going on in here. Oh, well, actually, you can see that we just forgot to call the function. So let's fix that, shall we? So we have to actually call our functions if we want them to do things. That's the first rule of programming. You have to actually call your functions if you want them to execute. Just thought I would let all of you novice programmers in on a really big secret that those of us who have been in the industry for a while have learned. It's like a really, you know, closely guarded secret. If you don't call a function, it doesn't do anything. That's a big one. You know, some of you may not understand what I'm talking about there. I know it's pretty advanced stuff, but that's actually, you know, if you think about it, that's actually what happens, shockingly. All right, so let's get this going like that, and now let's try to debug it, because we can't really debug code that doesn't get called, other than to say that it should have been called. All right, now we're getting somewhere. Okay. So first of all, what we're seeing here is we're blowing out our entity count. So oh, wait, what? Sim region? Did we forget to, oh. All right, sorry, we forgot to delete some code as well. We're not quite done. That needs to go away entirely. And we need to change that, that reference to it. This is supposed to be world unpacked. Oops, unpacked entity count, and this is supposed to be world max unpacked entity count. Let's see what else we got there. Oops. And this debug value here where we do the entity count, I suppose we can do that at the end of this where we just say what the entity count currently is running of the, or what the unpacked entity count of the world is. I guess. Fine. All right, back to debugging. What else we got? So it looks like here we did blow out this number. I'm curious here, though. Let me just make sure we're not still on our kind of junior programmer streak here of forgetting to call our functions. No, so we are actually, thankfully, calling repack entities as necessary. I was a little bit worried there that we weren't. So yeah, off we go. And at the end of this, we are correctly zeroing our unpacked entity count, which should mean that we can do this as many times as we want. And so when we're going through and doing this, I think, if I'm not mistaken, yeah, I think if I'm not mistaken that this should be a real check now. And it should have gotten initialized properly, right? Yeah, so I think that's all. Okay. So let's actually start debugging this. That looks like that is now an actual valid error, hopefully. We'll see. But let's see what's going on. All right, so I'm going to check the world here. And it's at least correctly like barfing on this, right? So that's good. Let's see where we're at in our... we're coming in here to our ensure region is unpacked call with our min and max chunks there. And one thing I would like to do is let's just look at what happens to the world itself as we come through these calls. I just want to make sure this is generally working at all. So here is us trying to unpack one min-max chunk here, right? And it looked like that literally unpacked nothing. Coming back through here, we got 90, 109. You can see us unpacking various regions. So that seems to be working fairly well so far, right? So I'm not sure what we're getting in terms of bugs here. And in terms of the call stack, this is all inside the world generation, right? You know what I might want to do too? Let me do one more thing that I think we've never actually done. Let me add one more thing too before I get too deep into debugging that I would like to have. We want to make sure you can only unpack once before you at least call to say that you want to check for repacking. So I want like a thing called unpack is open here, that when you call unpack we set, and then when you call repack we unset. So like in here, I want to say that you've opened up your unpack, and then in here where we do repack, I want to say, okay, you've closed it, right? And so when you call this, I'd like to assert that the unpack is open, although technically that's really not the part I care about. What I care more about, because you could call this as many times as you wanted, so that's really not the issue. What I want to avoid is multiple people calling this before they call the other one, right? So what I want to do here is assert that it's not open before you open it, and then here I want to assert that it is open before you close it, just for the moment, right? And I want to make sure that there are no unbalanced calls. But otherwise, I think we're okay. So let's take a look at where we're at here. Unfortunately, it's a little bit behind my head, but that's okay. So if we look in here, it looks like we're actually in the simulation part of things now. And so what I'm wondering, is this the first time that we're simulating something? Let's see if that's true. So for whatever reason, and I'm not sure how we introduced this error exactly, but for whatever reason, we seem to have introduced an error where generating our world doesn't cause a problem. For packing and unpacking, it all seems to work. But when we go to actually do our first simulation, that does fail. Right? And who knows why, right? We have no idea why, but we're going to have to figure it out, right? So looking at this particular part of the code, as we come in here, right? If we look at the world, it is correctly re-initialized, right? So it doesn't think that anything's unpacked. And so when we come in here, what we're saying is that we effectively get when asking for this region, which is not exceedingly large, right? That's totally reasonable. It's not some weird, crazy, like, number that doesn't make any sense. When we go to unpack this, this obviously should never execute currently because there is no time when these things are actually stored there. This part supposedly just unpacks like infinity items. Let's skip to like maybe here or something. So how many entities are in this block? 3. Hardly going to break the bank there. So is it possible? Are we getting like some kind of a... What's going on here? Are we getting some kind of like an infinite looping chain or something? It would be nice to be able to tell if that were the case. Here's one other thing I'm going to do, just as a check. So in here, where we do this sort of like first block, block next sort of thing, so, you know, we're pulling this stuff off of the set, where we remove this chunk and now we're going to like do a bunch of garbage with it, right? What I want to do is I want to check to make sure that this isn't like an infinite loop. And so the way I'm going to do that, although this isn't quite good enough, is I'm going to assert I'm going to create like a synthetic checker here, right? And what I'm going to do is I'm going to assert that my check block is never equal to my block, right? And what I want to do is, I know this is ridiculous. We'll sort of talk about what this is. Well, I'll just talk about it right now. So suppose I want to look to find out if this linked list has a repeat somewhere in it. So if the entire list repeated, then it would be sufficient for me to just take the first pointer to something, or really any pointer to anything in the entire list, right? And assert, as I loop through the list, that I don't hit it, right? Because as long as I don't hit that one, I know that the entire list doesn't loop around, right? And I can't really do it here the first time, right? I would have to do it one past the first time. Like I need a counter, which is what I was about to do, but there's another reason I'll do it, but we'll see this in a second. So we really want this. So what I'm trying to do here is basically say, all right, so suppose I want to check to make sure that this thing doesn't contain any cycles. Well, this is going to loop through the entire list, and if the entire list was just a circular list, so I'm just running around in circles and I'll never terminate, then I can just check to see if I hit any one of these blocks more than once. So the easiest way to do that is to just say, well, the first time through, I don't want to assert because obviously I'm going to process that first block. But every time thereafter, I could just check to see, like set it equal to first block and check to see whether they're equal at that point, right? And that would work. But what I want to add is another case here. And the reason for that is, suppose the linked list was like a list of like 50 things, and then just the last like 4 of them were in a cycle, right? So there's a bunch, and then there's a cycle at the very end, right? Well, what I'd like to do is be able to find that cycle at that tail as well. And so the way I wanted to do that was just say, look, if every second time I move my main pointer, if I have like another pointer that moves half as fast, no matter where the cycle is in the chain, eventually it'll catch up, right? Eventually. So I should be able to do something like this. And I could make this really any number I wanted. This could be 5, 10, 100, doesn't matter. And so all I really wanted to do there was like check to see if there were cycles. And that's one way to do it. It's not a very good way necessarily, but it is a way to do it, right? And so I was just curious if we found any cycles. I don't know that that's actually what's happening here, but I'm just curious to know. So we didn't see any there. I think I wrote that code correctly, but it's a little bit subtle to be fair. Also, that's supposed to be on the outside. Technically, I guess it could be there. All right. So, assuming I wrote that code properly, then we didn't have a cycle in there, and it looks like I did, right? We're decrementing the counter. If it equals 0, then we advance our check block and reset the counter. Oop. Nope. One more time. All right. So let's say I checked that properly, but let's be honest, I didn't do a particularly thorough job there. But let's just say that we assume that we don't have any cycles. And the reason I'm kind of only vaguely checking for that is because I'm not sure what we could have done that would have added cycles. So I suspect if we did do something wrong here, really what we're finding is something, either we're like over adding entities in some weird way, or what we're doing is when we're packing our entities back up, we're like packing them all at the place where we start instead of where they should actually go, or something like that, right? I think that's sort of more what's happening. It's a more likely bug, and so I'm going to look for that a little bit more aggressively instead. So, yeah. So looking at how this code is working, right, we're mapping something into the space of the chunks by taking whatever the entity pointer was and saying we want to make it relative to the unpack origin, which is the origin that we were told to unpack with the last time you started a sim region. Which is being stored here, and I think is what we expect. So, you know, just to kind of look back here. If we look at when we're doing that begin world change, you can see us storing the origin here. And so when we call this, I think that should be correct and should be sort of, you know, what we would expect to see. I don't see anything odd going on there. Similarly, this code doesn't really touch those positions at all. So it's really just going to be this one here that does. Where we update the dest p here shouldn't really matter. Like that really shouldn't matter. So this right here where we do our subtraction, we take the chunk position and the unpack origin there. That seems correct as well, right? And that delta is going to get applied to the entity as it comes out. And I don't think anything bizarre happens in register entity. I mean, nothing really goes on there. So this code here, where we're coming through and removing that world chunk there, let me see. So this part where we add the I don't know why we have a mutex for that. I guess because we allowed like multiple people to access this. Yeah, so that really could be made in line to what we're doing here as well, which I would prefer, but again, not really germane to this. So, looking at looking at this, I think we want this code to just be inline here. Oops, sorry. This code rather. And that ticket mutex should really just go on the unpack, right? And that just makes a lot more sense than having to take it each time through there. Doesn't really make much sense, but again, not really that relevant though. So I'm trying to think of a way to approach this debugging wise, and I can't really think of what to do other than maybe to take a look at the packing calls to see who is getting packed and why. So like, I want to see what this value is a lot of the time. Do I think it's repeating unnecessarily? I'm not really sure what the most expedient thing is. The only things I can think of are now sort of involved, right? So we're just going to have to do something involved. There's no shortcut, I don't think. So I'm going to take a look at the entity P here for the packing. And what I want to do is set the breakpoint here. I'm just looking at these values. And I'm just looking at the spread of these values. By the way, using remedy here to do something that you literally can't do in Visual Studio, which is watch values change as you run. Visual Studio's lag on the watch window makes this kind of debugging actually impossible. You just can't do it. You used to be able to in the old days, and then they made it so slow that you can't anymore. All right, so let's step through a couple more times and see. So it does seem like there's like a suspiciously large number of entities packed into this one particular cell. And I'm not sure whether that's to be expected or not in terms of the overall size of each individual chunk. I'm not sure how many things you would expect to see in any one of them. Overall, though, again, I'm not seeing any kind of really sort of ridiculous, like, oh my god, like, how could you possibly ever imagine having this many of the same chunk value? It looks like there's entities spread out among the chunks, like you would think. And they have various coordinates throughout the, -10 to 10 range on everybody. Which is, what I would kind of expect. So I'm not really sure, again, where this, like, difference is coming from, where, we should have had the same exact number unpacked before we made the change as after we made the change, and yet we don't. And so where that's coming from, I really am not sure. I'm going to go ahead and look now towards this set of code here. So I'm going to let it fail, first of all. And in here, oh, you know what? There is something I just thought of that maybe would be related, which is that where we sort of do our looping, if this was broken, which it might well be, because we never tested it, then some of our stuff that probes for nearby entities would fail, and that could have caused a problem. Let's take a look. I just need to get to one of... Oh, well, you know what I'll do. Let's double check that code. All right, so in here we start off with an iterator, and it didn't find anything. Let's try that again and step into this. Here we go. So let's see what we've got. Here's our entity hash, right? We're going to loop over this and see what we can find. So while we're inside this array bounds, we look to see if we find one. We just loop over everything in here. And then let's see if we find anything. So we are finding stuff. Right, that does seem to be finding stuff. So, I mean, I'm not seeing a lot of reason to be suspicious. That all looks fine to me. So yeah, I don't think that's probably our problem either. So I'm going to let this run to the crash site. I'm going to set a breakpoint on the outer piece, meaning this part right here. And so we know that after the world gets created, which all seems to work without having to unpack a region that has too many things in it, the first time we try to do one for sim is when we fail. So if I look through here, I just want to look at what the pattern is of things that get unpacked in terms of chunks. See if I can see anything that's a hint there as to what we did wrong. So when we go into ensure region is unpacked here, what I'd like to do is say if, we take a look at where the majority of these entities are coming from. So like in here, for example, right? If I just go ahead and look at this block stuff here, I want to look at who is responsible for the majority of blocks. So like -1, -1, 0. 0, -1, 0. How many entities have we already added? That's an incredible number of entities. You can sort of see like, yeah, like what's going on there. So it also almost feels like, I wonder if somehow when I did the transformation on that code, I am leaving the blocks in there somehow so that they don't actually get removed. But remove world chunk, right, like should do that. And so after calling this, there should be no way of, like, it shouldn't ever like duplicate those entities out unless I'm missing something, you know, which maybe I am. But I really don't see how. So another thing that I could do here actually is track the pack unpack level. So for example, and I guess we sort of already do that. Well, no. So in here we have last used entity storage index. And last used entity storage index, anytime you create an entity, right? If we look at that call, when we do create entity and we pass it an entity ID, let me just go ahead and look at the places where this is called. Yeah. So allocate entity ID is just going to increment this thing. So that's how many entities we think we made, if that makes sense, that we actually asked for. And if we track our pack unpack count, what we should see is that the number of total entities that we've packed minus the total number of entities that we've unpacked should always like equal that number. We should never be able to have like a higher number than that, right? So what I might do is say, let's see what happens if we track that. So in here I just have a like, that's like, well, I don't read that. I can just be like, a packed or entity total packs minus unpacks, right? And I can even make that an S32 so that if we do have an error there and it goes negative, we can see that it's negative, right? So in here, every time that we go into this call to do this, this is an entity unpack. So we would deck down the number, right? And then any time that we go in here and push an entity in, we'd up the number, right? And so what we should see is those numbers should equal each other out, right? The total number of allocated entities should match the total number that we've packed. And so I'm just curious to see if that actually happens, or if we've got an issue there, right? So let's take a look and just see. So looking at these, There is a discrepancy between those numbers, and I would like to know where it comes from, but the discrepancy isn't large. So even though I think we should track that down, because maybe we allocate some IDs for entities like reserved space or something. What is the discrepancy actually? So 21421492 minus, oops, 21523. So there's 31 entities unaccounted for there, right? 31 allocated IDs unaccounted for. And so we do want to take a look at that, but again, not really gonna explain where our extra entities came from, I don't think. So all right. So that means the total number of entities that we packed into the system was 21,000. The total number we created was 21,523. How we created entities and never packed them, I'm not sure, right? And so that's what we want to go look at. But if anything, that would mean that when we were unpacking versus packing, we didn't pack as many. So that should actually that's the opposite problem as to what we're seeing with this bug. So again, not really sure where that's coming from. Okay. So we know we haven't called the packing routine too many times and ended up duplicating entities or something like that. That doesn't seem to be happening. But again, what we don't know, right, is where where we're getting this extra entity throughput. So one thing I'm curious about is visually, can we get a clue? If I was to go into the system and start expanding that number out, so what number would we need? If in here I said the max entity count was something more, right? Congratulations, you can unpack 4 times the entities that you thought you could, right? Does it keep? Will it still have a problem? Is there any amount of headroom that would prevent it from being the case or not, right? And that's what I want to see. It looks like this blows out the hash storage, which is, I guess, what you would expect. So I suppose that would have to be... that size would have to be increased as well. And maybe, like I said, maybe we do that. And so in here, let's make this a dial, because I would like to be able to run with different numbers and see what happens. So in the sim region, I'm going to define a thing here that's or max sim region entity count will just be something that I'm going to define. And so I'm going to define that to be 4 times 8192, and then everybody else can use that. So the entity hash can do that, and we can do that here. And I don't actually want it to be that big. I want it to be significantly lower than that, I suspect. But like I said, I just want to see what number are we getting. So what is the actual number of things that we unpack? Because I have no idea, since it just crashes out and says, hey, we don't have room for unpacking that many. So how many would you unpack if you could, right? So the answer is 15,383 is how many it would like to unpack, right? Which is underneath the total number that there are. So we don't have a smoking gun that says, hey, we're obviously unpacking wrong. But it does seem ridiculous that somehow we're unpacking 15,000 entities now, but we haven't done anything to the code other than just change where we're unpacking them. So we shouldn't have been able to exceed the number by such a crazy amount in code that should be doing literally the same thing. So, all right, next question. If we draw this junk, do we see anything that would give us a clue. Now, one thing I would like to do is maybe disable lighting for now, because again, the lighting storage isn't going to fit with this much stuff, because the way we send these pieces of light information down, obviously, into the lookup table is a fixed size. So that light data width isn't going to cut it. If you look at where that's specified, you can see we only have so many, and we are currently a fairly poor system for managing the lighting, so that's just not going to really work. So I'm not sure exactly what to do about that. I could make this larger temporarily. I'm not sure I really want to, because I'm not sure that will actually work through the renderer, but we can do it temporarily just to see, I suppose, because I just want to see what the screen looks like. You know what I'm saying? How many of these do we have? Ugh. I'm pretty sure we can't even do this because we wouldn't be able to submit these textures. They're going to be too large, right? So we may have to just disable lighting temporarily while we take a look at this. That's nuts. All right. So how can I turn lighting off kind of permanently while we look at this? Because I really just don't want... I think the easiest way would probably be to do something like this. So if we do lighting enabled here and set this up where we do enable lighting, I think I might be able to just do that. I don't know what this does. We'll see. It looks like that only changes the enabling of the lighting there. We need a kill switch for lighting. I just don't think we've ever engineered one. Oh, is enable lighting never even called? Alright, even worse. So we don't really have a way of killing this, and I would like one to kill this because I don't really want to have to update it. So maybe inside the lighting code where we actually, do this work, maybe I can just add a kill switch in there. We don't care about that so much. So where we're actually doing all of our compute light propagation, is there really no switch that turns this on and off? Because I thought we kind of did that at some point. We had a switch, but I guess that switch got eliminated. I mean, we have an if 0 here, but it's not really what I had in mind. So inside Handmade World Mode, where we actually do the lighting, does that actually have anything? No, it really doesn't. So it looks like we just don't have a way to really do much about this. We've got an updating lighting option here, but it's kind of janky, right? We've got updating lighting and show lighting, and in terms of these getting set, yeah, this is all just kind of like old code that's kind of just gone now. How are those getting set at all though right now? Like, if these must have to get set to something at some point, right? In order for lighting to actually get enabled. So I'm just wondering how that is happening. Yeah, I don't see it. So in terms of calling output lighting textures, world mode updating lighting should have to be set to true somewhere, right? But if it's never set anywhere, how is that possible? Oh, so it did. How did it not find that when I looked for it before? That's lame. Anyway, so inside Play Worlds, where we're setting this here, I don't know to what extent I can do this and have that mean anything, but we're going to try. And at some point, I guess when we do our lighting pass, yeah. So it looks like this just always gets called. Like when we're pushing the cube stuff on, right, every time we push one of these cubes on, it needs to allocate one of those lighting points. And I guess the light store, so this part here where this is getting pushed on though, if lighting was not enabled, then I suppose that would actually allow us to prevent that part from out flooding. So it does seem to me like somebody like in here, when this render group gets set up, somebody has to start having the lighting take effect, right? Somebody in here, this part, that has to actually occur. So who is doing that? And could we make them follow the same flag so that we don't have to worry about it? So if this is render group, lighting enabled is 0. And so right here, I guess, is where that gets set to 1. So when we actually put those on there, right? And so I assume what we want to do is don't push those down in that case, where the lighting is not actually happening, right? So inside world mode, if we did just check that flag and not set up the lighting, what's that called? Push lighting. This part here, I assume that we can get away with that. I don't really know, but we'll try. Interesting. So we got by that part okay, but now when we're doing sort of load traversables here, and this is the next, this would be the next time through. So we made it through the first loop fine. But in here, where we're looking at this entity reference, it looks like for some reason these are not being restored to 0 properly in this case. I mean, that is one change we made. The one change that we consciously made was we just passed 0 for the sim region. Could that really have caused all of this problem? I doubt it. But maybe it did. if you remember, in repack entities as necessary, I didn't pass the sim region here. So, you know, really this code was supposed to look like this. And I didn't want to deal with it right now. I want to deal with it later, but maybe we need to sort of analyze it first this way and make sure that we haven't messed up anything before and actually go ahead and do the change I said I was going to do first. How could that really be the problem, though? Doesn't really make sense. But either way. Okay, so yeah, that's not the problem. This is like a separate issue. Good, because I was like, that shouldn't have done anything, what we're doing there. So I'm not sure what we're getting a problem with here, but again, it's probably all stems from the same bug that we have that we just don't know which problem we've introduced here. But as we're looping over the entities in the sim region here, oh, wait. I totally screwed this up. Okay. So this may actually explain things. And I had the information necessary to do the right thing, and I just didn't. We don't clear this array when we start. The entity hash occupancy table tells us whether there's something there. So actually my iterator is total garbage right now. Oh, wow. Okay. Wow. All right. Did you see that bug? That was a pretty stupid one on my part. I feel like that may be a full hour thing because I literally looked at it at the beginning of stream and I knew that I needed to obey that hash occupancy. I said that and then I proceeded to totally ignore it, right? I mean, you remember that happening, I assume. So yeah, I feel like, you can't even really see that that's on my head. I need to like adjust this so you can. There we go. So I think what we need to do here is say, add that occupancy check back in, and that honestly may be all there actually was to it. So what we need to do here is check the hash occupancy of this particular entry, right? And then we need to go ahead and get it. So like get hash from ID, not that one. So this call right here where we do like is empty, that I think is what we actually need to do and weren't doing. So we say for this hash index, if this thing is not empty, then we can get the pointer. But otherwise, we can't. Right? Make sense? And so we were looping over a bunch of false entities. No wonder they all, like, got confused and perhaps remapped in weird ways, because that was just total garbage. So I think that may be all the problem there was. There's probably other bugs, let's be honest. If I missed that one, which I literally said we had at the outset of the entire thing, then the chances are high that I've done other stupid things as well. Okay, let's take a look at what's going on here. So let's start by seeing what our profiler is telling us is going on here. I'm going to switch this to release mode just for a second, so I can see what's going on. But yeah, that was really stupid. I don't know why I did that. It's just quite dumb. All right. So if we look at what's going on here, we can see there's some weird, like there's way more arena occupancy than there should be. So we're getting bugs. We definitely still have bugs in there. And if we look at the profiling, spending a ton of time in this repack, which we wouldn't expect. So we've still got some pretty bad mojo happening here. So why? What's going on, right? And I have no idea, so we're gonna have to figure it out. All right, so back to debug mode for now. I also want to look now to see if that changed anything about our unpack, although based on that, I guess it didn't. So this was an unrelated problem that I just also had that was separate, right? So what I want to do here is let's set a breakpoint in begin sim. And in here, I want to look at the world structure. And I want to see how many we get. So yeah, this was an unrelated problem. So that was just also a problem. And so we're right back to square one. Now, we did have to fix the other problem, so it's not like... it's not like we didn't need to find that bug, but it is the case that we really have no idea why the change we made would have affected the system the way that it did. So we're still just as in the dark as to why we're getting such an unusual behavior out of this. It would seem like, my expectation would be that we're handling the positions incorrectly in some way because that's the most subtle part of this system, and I'm not sure what else really could be going wrong there because it's the thing that determines where you get packed as well. So that's the thing that I would have most suspected to be wrong, would have been that. And if you look at how the entities are working in here, I honestly can't see what the problem would be there because they seem at least to be doing they seem to be doing it. Oh, wow. So this is just going to overwrite this right here. So why that is above the copy, I have no idea. This was just an owl of shame day. It seems like we got all the hard stuff right, perhaps, and like two really stupid things we got wrong. But I guess that's just how programming goes sometimes. So what are you going to do? There's not much you can do. Just a reminder of how bad our lighting is. Did you notice... that although our world gen is quite slow, this is debug mode when you're not running with lighting on, right? And so, kind of ridiculous, right? How much, like, our entire frame time is completely dominated by lighting, such that the debug version of the game runs pretty much at speed. Maybe not 60, but at least 30. Just fine, and that's kind of absurd. So that just gives you an idea of just how much we need to improve the lighting because it's, pretty much we could just be running the game in debug if we really wanted to, if it wasn't for the fact that lighting is there. one thing I might do just based on that is to say, look, are we building in debug or not? And maybe set this based on that. I don't know. That's a tough one to say. Anyway, I think that means now we're fine. And if I do sort of build in release mode here, here we go. I think we should be back to normal. Looks like we are. All right, so I'm going to call that a day. And I think that sets us up pretty well because it looks like, yeah, if it wasn't for those two pretty stupid things that I missed, everything seemed to be fine. And so all we really need to do now is take the next step tomorrow of not always repacking. And then and that's basically the only thing we really needed to do. And then we're good, right? And we're ready to make our packing function actually throw things away if it would like to, right? So I think that's all we really need to do here. And that puts us in good shape for tomorrow. I'll go to a brief Q&A in case anyone has any questions about that. And I'll readjust my camera here a little bit. Will the packed entity be a separate struct, and what is the plan of adding, removing data? So basically what I'd like to do there is at first we will probably not make it be a separate struct because I don't care enough about it at the outset. So we'll leave it as a struct the way it is now. But what I'll do is I'll add a watermark to the struct, and we just won't save the back half of it, right? So all the data that we don't mind throwing away, and that can just be reinitialized later during unpack, we'll just stick that on the end. And the reason for that is I just don't want people's lives to become more complicated, right? But at the sort of more towards the end of development, when I'm pretty confident of how I want everything to work, I will make two totally separate data stores. One will be the entity struct that gets used during simulation and that's in the cache area. And the other will be some kind of a like hand-tuned packing of that. Probably like almost maybe even a compressed representation. So we may even do something where we like sort of just have a like encoding of what's in here as like a flag array or something, or maybe even a tagged thing. It's like, here's the tag that says what's here, and then the data for it, what's here, the data for it, what's here, then the data for it. So that we don't really have to store anything that wasn't relevant to that particular entity. Something like that. But I will let that play out. I don't have a particular requirement for it. I'll let that play out as it wants to as we go. I had a question regarding the arena graph in the profiler, though it may have changed this episode and you may not be able to display it in its current state. It was about why there was separation between the ground chunks. The first group all were green, but every X amount there is a gray value that separated them. What was the separation? Yeah, so that's something we want to look into eventually, actually, and I'm not 100% sure what it is, but I will explain what's going on there. So if you look at what happens in the allocation, so if I use, use chunk space. So inside use chunk space, you can see that what happens is it looks for free blocks that can store world data. And if it doesn't have one, right? So if it has no free space left, then what it's going to do is it's going to allocate space for a new one, right? Looking at the way this is written, it looks like this, right? Well, okay, so even just looking at this, I can tell you what the problem is. So what ends up happening is every block is allocated as a 1 megabyte block because that's just what we set it up as. We can change that to anything we want, but blocks get allocated as 1 megabyte. The world entities get packed in granularities of 64K. That's 1 shifted up 16, right? That's 64K of data. So the question is, how many of those can you fit in a 1 megabyte block, right? I don't know, 1024 times 1024 divided by 64 divided by 1024. Well, I should get exactly 16 of them, right? But lo and behold, when I run my application, what do I see? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and right? So what's going on here? Well, I was going to say we have to look into it more, but even just looking into it in the 10 seconds it took me to explain it, I can tell you what the problem is. So world entity blocks are the things we're storing. There is 64K of data in the block, but then a bunch of crap. There's an entity count, some low entity indices. I don't even know what those are, right? This stuff has been here since time immemorial. This stuff adds to the 16K, right? And so what we end up with is, adds to the 64K. So we end up with is something that's 64K plus a little bit, and that little bit adds up over the 15 that we put in there, such that when you go to put the 16th one, well, if there's even 1 byte more used, you can't put one in there, because 16 fits exactly into 1 megabyte. So what we'd rather do is have the entity data size actually be 64K minus whatever this nonsense is here, right? So let's just do that now, because you brought it up. We might as well do it. And so if we go in here and say, what's low entity index, right? Here's my compile. I just want to first see, does anyone use this? And if so, what do they use it for, right? So if I come in here and just say that's a new thing that's got an underscore under it, does it still get used? And if so, who is using it? Please tell me, right? So no one's using that thing, so that can go away. Does anyone use entity count? I assume they do, because they would need to know in order for the entity size. So I assume these two values are used here, but let's just validate that fact. So I'm going to compile it without that low entity index stuff at all, right? Here's me running. Everything seems fine, right? No issues. Entity data size presumably still needs to be used. Entity count, is it used? I think it is, yeah. Now, we probably don't need to use it because this string could probably be impacted as it is. I don't care, though, because this is fine. That's a pointer. It's 8 bytes long at most. These are both 4 bytes long, so 2 of them is another 8. So really, we just need to say, hey, we need at least 16 bytes of headroom to store our crap. So just leave that room, right? Now when we run, we should pack optimally, hopefully, if there isn't another problem besides the one we just addressed. And hey, look, we pretty much do. Although it looks like for some reason there's still a little bit of leftover space here on some of these where they can't. I don't know why, and so that would require us looking into this a little bit more. It may have to do with entities being too large to fit or something. Well, then that shouldn't happen. So I'm not really sure why there's empty space on those, but now you can see we're filling some of them up properly. Why is there extra space on any of these now, though? I don't know. That should have either filled all of them or none of them. And so the fact that it did neither of those two things is certainly odd. So that's a puzzle. I do suppose that since we are sharing this arena with other people, that may have something to do with it. Because if anyone else tried to allocate something during that time, we wouldn't place it there. It would get placed somewhere else. So if the world arena were used in some kind of a temp storage fashion, that could potentially explain it, but I'm not sure. What we could do is make the world arena isolated for now and see. So for example, if we did want to do that, what we could do there is just say, so inside here, if I look at create world, so in here where it gets past this parent arena, if instead what I wanted to do was just have this thing be a self-contained arena, right? I could say that and get rid of this. And in that case, this would become a bootstrap. You know what I'm saying? And so in that case, it would be this. Right? And then what we would do is anywhere in here where we were looking at the arena, we just need an ampersand on that. But that would allow it to keep its own separate arena for memory and track separately. And then we can ensure that none of what I just said is happening there. So what is get world chunk? So that's where the extra memory is coming from. You can see it right here in get world chunk. You are having an allocation here to you're having an allocation there that's keeping the headers. And so anytime you allocate one of those, again, you cannot fit optimally in there. We can fix that, and we should, I think, right? I'm just going to show this now. I think we do not need to keep it as a separate arena, so I probably will just back that change out, but I just wanted to see. So you can see here if we did that, we'd have a separate arena here. And you can see the storage works out to basically the same, though. Right. So I'm not sure if we want that or not. It's hard to say. We would have to then track this memory separately, and I'm not really sure I want to do that. So I think I'll just go ahead and back that out, but it is pretty simple to do there. All right, so the question is, how do we avoid this problem, right? Because you can see what's happening there. And by the way, this is just another reason why visualization is so good. It shows us exactly where we're wasting our space, right? And that's pretty cool. So anyway, you can see what the problem is. When we do get world chunk, in here, we end up with a situation where we need to allocate this sort of header that goes on the front of things. And what happens is that header is just not very large, right? If you look at a world chunk, it's this tiny little thing. And so we're using a little bit extra memory in those blocks that every time we have to allocate the header. That means now we can't fit that 64K in on the end. But remember, we've got free lists here. So what we can do instead is say when our free list gets exhausted, let's not do this where we push a single thing on the free list and take up a little tiny chunk in our arena. Let's take up a whole 64K. Why not, right? So instead what we can do is say, all right, let's make a chunk array and let's push a whole array of these things on there. Like this. And the number that we're going to push on, let's say we made this more systemic and say the world block size is this. Well, now what we can do is we can create a number which we can call chunks per block or something like that. Or chunk count per block. And we can take the number of bytes that are in one of the blocks that we use for storage and just say how many of them would fit. Once we do that, we can allocate exactly that many, right? And then we just loop chunk index is less than the count per block. And we just push all of these onto our free list, right? So in here where we were previously gonna like sort of initialize this thing like this, what we can do is say, well, let's push for each one of these, let's take the chunk array plus our chunk index, right? Let's make that be the chunk we're working with. Oops. Right. Let's set the world's first free chunk to be that chunk, but the next in hash of this one to be whatever's in there, right? So we're just kind of daisy chaining these on. You know what I'm saying? And we could do that even easier if we wanted to, but basically what we're doing is just pushing a whole bunch of these on at once. And then we'll just pull out of the free list from then on out, right? Now I believe if I did that correctly, and of course I didn't, make sure I got that right. Now for free chunk, let's allocate this many of those. We're going to go through each of them here, and we're going to say that, oh, no, that's totally wrong. Sorry. It's new chunk, next in hash, is whatever the current thing is on the top of the list, which is nothing when we first do it, and then that's the new top guy. So we just pushed them all on the free list, and other than that typo, I think we probably did that properly. And now, by allocating them in bulk, we should have a perfectly packed memory structure. And as you can see, we definitely do, right? And so that's just the next unused block there, right? And what you can see is now this right here is all of the world chunks actually got allocated like right here. And then from then on, we were fine for the rest of the way. However, you can see we lost some here. And I think that is because this doesn't fit evenly. So if you look, the total number of these doesn't quite add up the way that it should, I would assume. Well, actually, no. You know what? That's not the problem. Never mind. That would leave a sliver in a different place. What that actually is the first time out, there's people who've used this arena for other things, right? And if we could zoom in there, which is something we want to add eventually, I think, you can see it's handmade world.cbp taking up that 5K. That's what's offsetting us so that we can't fill up that part. So that's always going to be the case because that's the world struct itself that's sitting in there causing that problem, right? So that's fine. But then, yeah, now everybody will be perfectly packed from now on, and off we go. Did you ever figure out memlarge pages for virtual alloc? Is that what you're talking about? No, memlarge pages for virtual alloc is just if you want to use 2 meg pages, right? I think. So Enthusiast says, how did people do memory management in the era of Commodore 64? It is so luxurious nowadays with all these amounts of memory we have at our machines. Yeah, well, in the Commodore 64 days, while you can look at it 2 ways. One, obviously, they don't have the luxury of doing all this crazy stuff we're doing nowadays because computers are so amazing. We have so much more horsepower. But we're expected to do a lot more with it, right? And so it's kind of a double-edged sword. In the Commodore 64 days, you didn't even have to think about memory management as a thing because when you only have a 64K buffer total that you're ever going to do stuff with, the things you can do with that are so limited that you can plan them all out ahead of time, right? And so you're not going to do memory management. Like, no one's going to allocate things, really. You're just going to plan, like, here's the buffers we use for each exact thing, and here's where they are. And in different modes of the game, we use different layouts, and that's it. And everything's hard-coded directly to that. There's no, like, variable allocation kind of stuff that happens there, for the most part. That's my assumption, anyway. The place where that doesn't entirely happen is if you did one of those interpreted systems, like maybe ScumVM or the Infocom Z machine. Those may have sort of did it a little differently because they are sort of virtual machines, so they may have been able to do more of a memory paging kind of a thing. But at the same time, they really had nowhere to write the memory to, so I don't know to what extent they really did anything like that. Right? All right. So let's go ahead and close this down for today. Thank you, everybody, for joining me for an episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow the series at home, you can always go to handmadehero.org and pre-order the game, because it comes with the source code, which I upload every night, so you can play around with it at home and do your own experimentation with it. I'll be back tomorrow when we will take the next step, which is to try and keep entities around frame to frame as a cache. And then if that works out well, which we'll see whether it does or it doesn't, we'll see how much work we have to do for that. But if we have time, and that works out well, we'll also take the step of packing entities in a limited sense during that sort of phase. So that's what we'll be doing tomorrow. Hope to see you back here for that. Until then, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.